All right, so this one is Fibonacci. It is what it sounds like. It is as insane as it sounds. So we're gonna get a generic Fibonacci that takes in a single number, and it gives us the next Fibonacci number. I'm sorry, the previous Fibonacci number rather. So if we pass in 3, the Fibonacci sequence number that comes before 3 is 2. If we pass in 8, wait, is this wrong?
No, it's the index.
Oh, the index. Right.
Index in Fibonacci.
Yeah. Thank you. It's the value. Yeah, I lined them up.
Oh, that's easy.
Here. Yeah, easy. What's the big deal? Okay, I told Theo before this we started this one here that I'm going to for his health. I'm not gonna. I have a bunch of solutions I want to show. We don't really have a lot of time anyway. So if it's all right with you, I would like to just show you. There's a couple different solutions, and we can just tackle at them if that's all right.
Can I? So what you're saying is my solution of creating one giant Fibonacci type with all of the key value or all of the indexes mapped to the right number is not the right solution?
I don't know. I don't know if that would work over the long term. Here, I'll show you. So here's one of them. There might be some cool, fun things that are kind of new that I'll show you here. So starting from the top, we have t extends number. Okay, that part we knew. This is these 3 arguments here are a way of doing temporary storage while you're creating a type that like does work. You can always hide this from your end user by making like Fibonacci internal or something and calling that as the only, you would just grab all of this, put it somewhere else and do like fib, internal or whatever, and then pass in your thing and go from there. But, it's common in the challenges, and when you're doing recursive types in TypeScript, the worst thing in TypeScript right today in January 2023 is arithmetic. Like there's really no way to do math to add 1 plus 1. One of the extreme challenges is add. Like add 1 plus 3. It's an extreme level challenge. It's one of the hardest TypeScript challenges. And the reason is because there's no facility in the language to do that. And also that challenge asks you to go like up to big int level of complexity, of size rather. And there's a recursion limit in TypeScript that limits your ability to do like big math. So you can't actually rely on this to go super far. So anywho.
To be fair, if I had it my way, by the time you've done more than one nested ternary in your type definition, we would have thrown you out long ago. This is chaos. This is utter chaos. Why are we using emojis as key strings to hold places?
It's a cute little thing. So basically the emojis can be switched out.
Like just to be clear, you're down to use emojis in your arrays for placeholders, but you're not down to use something other than T to describe what the hell is going on. I just want to be fully clear.
I'm totally down. Actually,
okay, cool.
What is it? Sidrosaurus, his repo's like Typefest. He has like a hard rule that like no T, just give it a name that people will understand. And I quite like that rule. In this case, the formatting being the way it is, and also the T is mostly because I just want to fit it on a screen, like very narrow, so people can read it, nice and big. But so this thing, you don't have to do this. A lot of people do this. They'll just put a number literal there, or they'll put unknown, because it doesn't matter what the value is. You're never actually looking into that value. So let's look at it, and I'll show you. So, oops.
Yep.
So previous is like the kind of array of previous items. Current is the tuple of the current items, and then we have our index. So this is just like a number. And notice that for all of these things, we're never actually, for current and current index, we're never actually grabbing what any value is. We're just checking the length. So we're saying some length extends t. Well, t is our index that we're supposed to stop at. So this is saying, did we reach our stopping point yet? Okay, if we did, then give me the current Fibonacci number. We're like building it up. If we didn't, then we have to keep recursing. Are you with me on that part?
Yes, I hate this.
Okay. Hatred is welcome, is a welcome response. So in this case,
realize you were literally just appending to a type array and then keeping track of how long it gets.
There's no other way. Yeah, it sucks. It really sucks. There's no other way to do it in TypeScript.
Does this suck though? Can you give me one practical use case where being able to do this correctly would be useful?
Yeah. So for example, there's like includes, join is another one that gets used in some libraries. If you look around, I can show you, I'd be happy to take that challenge. I can show you a couple places where legit, like libraries like Zod, or like I was saying, React Query, or other libraries, Ramda, Lodash, these things use stuff
where
like this.
It's valuable to in the type layer, not at runtime, do something like calculating a dynamic length based on a number input.
Calculating a dynamic.
I'm trying to find, like, I'm trying to bridge the gap of why would I need numerics in my type layer and not in my actual application.
I would be happy to give you some examples. I don't have it right like handy, but yeah, there are weird situations where it does come up. It's not common. I'll give you that. I mean, this is not like a everyday, woke up and got out of bed and did some recursive types in TypeScript. This is another one. It's simpler. It does a very similar sort of thing. It's just using the like same sort of concept. The structure down here is a little different. But I want to show this. We can skip that one because it's pretty similar. I want to show this other example, which takes a kind of a different approach. So what a lot of people like to do is make helper types. I'm a big fan of that because it at least breaks up the logic of what the hell is going on here. And so we can see here, like, it shows us we're handling the base cases. This is just specific to the Fibonacci sequence. So if you get the number 0, then like, okay, it's 0. If you get 1, it's 1. But after that, we're just adding two numbers together. That's how Fibonacci is defined. And we're subtracting the current value from the 1, 2 ago or the 1, 1 ago. So basically this does this creates the addition subtraction thing. So I just told you a second ago that like this only will work to a certain level of recursion. I think it's like 44 or 100 right now that it's been set at. It changes every couple releases. But yeah, this is just a different way of solving it using like helper types, I guess is why I wanted to show this one.
The last time it took over 10 lines to implement add and subtraction, I questioned why I was taking a class about assembly. What are we doing?
I'm very tempted to just show, I have it here. It's a bit off topic, but I'm tempted to show you some of the solutions for subtract. They're like hundreds of lines long in some cases.
Oh no.
Maybe not hundreds, but like 100, definitely.
I hate this so much.
What
you don't need to do arithmetic in your type layer.
I'll make you hate it more. What you have to end up doing to get into big numbers to beat the recursion limit is you have to end up building like a base register system where you keep track of the value at every digit and implement carrying. So, if you get to 9, you have to carry the next decimal place to 1 or whatever. And all of that has to be done on a per character basis with strings because there's just a difference in the implementation. For strings, you can go much deeper in terms of recursion. And then there's tricks you can do for multiplication to like skip having to do certain levels of recursions by doing them all at once instead of nesting every time. Theo, I can give you lots of nightmare fuel if you like.
Because we have found so many creative ways to write code that will never actually run.
There is a bit of why here, like why do this in your type system? I would say a lot maybe, but yeah, a little bit for this one. It's a learning exercise. We got to give it some credit. It's not intended to be something you would use in code, or at least I would hope no one uses in code, but you get it. Cool.
I just want to see those more practical examples.
You know what? I will be taken up on that challenge. That's totally legit. Some of them are, many of them are not. Almost all of them are not. But I would say out of 140, there are about, not counting the built-ins. Of course, we all know like pick and omit and exclude, like those things are like, we all agree are highly useful. Those are the easy set. Of the rest of them, of the remaining 130, I think about 15 of them are like, oh, I could see myself using that. And maybe 5 of them are like, I will definitely use that skill, that particular type. The rest of them are just like learning how to work with this stuff, how to see it and read it.